Namaste student, this is Sanjay Nath. Today's session is on rotation and revolution of the earth, chapter 3. In this session we'll specially learn about revolution of the earth. In the previous session we already discussed about rotation. This is part 2 ICSE standard 9. Now we'll understand what is earth revolution. A revolution occurs as the earth moves around the sun called annual motion. As you can see in this animation, Earth on its own orbit revolving about the Sun on a particular path, and same time it is also rotating on its own axis. As you can see, even all other planets are doing the same. Time of revolution is 365 1/4 days, that equals to 8766 hours. This is adjusted after every 4 years called leap year. The speed of the Earth's revolution is about 18 miles per second on its own orbit. Now we'll understand Earth's revolution and its first major effect. Due to revolution of the Earth on its orbital path, once in a year, Earth is near to the Sun, and this position is perihelion and is on 3rd of January. The distance from the Sun would be 146 million kilometers. At this point or on this particular orbital path, when the Earth is closer to the Sun, the Earth moves faster. Whereas on the Earth on its orbital path, farther from the Sun, this position is called aphelion, and the date is 4th of July, and the distance is about 151 million kilometers from the Sun. This position is called aphelion. On this orbital path farther from the Sun, Earth moves slower. Now we'll learn some fact about the perihelion and aphelion position. When the Earth is farther from the Sun, the direct rays will fall on northern hemisphere, that keeps the northern hemisphere warm and hot. As you know that the northern hemisphere is more covered with the land mass, the Earth radiates more heat and it keeps the northern hemisphere warmer. Whereas on the perihelion position, the direct rays will fall on southern hemisphere, and northern hemisphere will be deprived of direct sun rays, that keeps the northern hemisphere cooler. Due to this reason, the northern hemisphere is relatively cooler and experience winter. Now we'll understand the perihelion and aphelion position of the Earth about the Sun with the help of a video. As you can see, the Earth revolving about the Sun in a unique elliptical path or the orbit. This is the latest information about the revolution of the Earth about the Sun. Now while the Earth is revolving about the Sun, there are positions that we have demarcated here. As you can see, this closest position of the Earth about the Sun is the perihelion, and the farthest position of the Earth from the Sun is called the aphelion. At one point of time, the Earth that revolves about the Sun will be closer to the Sun. At another point of time, the Earth is a little bit farther from the Sun. Now this position of Earth about the Sun during revolution, it oscillates with certain interval, the perihelion and aphelion position. Now we'll learn the major effects of the Earth revolution and some facts. Variation in the length of the day. Northern hemisphere is inclined toward the Sun for 6 months and southern hemisphere during other 6 months. As you can see, with the help of the diagram we'll understand what are the major effects. There are 4 Earths has been shown on this diagram. These are the different position of Earth in a year. On 21st of March, day and night length on equator is equal. It is due to the sunshine vertical over the equator. Same condition is also observed on 22nd of September. Day and night length on equator is equal due to the vertical rays of the Sun falling over the equator. On 21st June, the vertical rays of the Sun will fall on Tropic of Cancer. It is due to the inclination of the Earth 23 degree 30 minutes and facing towards the Sun. On that day, the Arctic Circle will experience 24 hours of daylight and Antarctic Circle will experience 24 hours of darkness. Same situation is also seen on 21st of December. Vertical rays will fall on Tropic of Capricorn in southern hemisphere. This is due to the inclination of the Earth toward the Sun. This time the southern hemisphere is facing toward the Sun. On this day, Arctic Circle will experience 24 hours of darkness and Antarctic Circle will experience 24 hours of daylight. Now we'll see some major effects of Earth revolution and visual interpretation. This is an extended learning. As you can see, Earth on its own axis rotating, axis of the Earth, North Pole and South Pole, illuminated part, 23.5 degree tilted on its own axis. Relationship between the location of the overhead sun and the seasons we'll learn. While the Earth is revolving about the sun, the direct rays of the sun will fall on Earth at 90 degree is called overhead sun. As you can see, while it is revolving and rotating, the circle of illumination remain constant. Spring equinox, 21st or 22nd March. As you can see, the direct sunlight is falling on equator at 90 degree angle. Northern hemisphere will experience spring equinox and southern hemisphere will experience autumn equinox. These are some of the important latitudes and their angle of the sun rays falling on different latitudes. Also we can see the length of the days. 12 hours of day and 12 hours of night will experience. Now we'll see the position of the Earth about the sun. Summer solstice, 21st or 22nd June. As you can see, the direct rays of the sun will fall on Tropic of Cancer at 90 degree angle, and you can see the part of illumination. And northern hemisphere will experience summer solstice and southern hemisphere will experience winter solstice. At this position, Earth will be tilted at 23 degree and half facing towards the sun. You can see the angle of sun rays at different latitude. All the important latitudes are marked. Places above Arctic Circle experience 24 hours of daylight. Places below Antarctic Circle experience 24 hours of darkness. Now we'll see autumn equinox, 22nd of September. The direct sunlight will fall on equator at 90 degree angle. As you can see in this visual, northern hemisphere will experience autumn equinox, southern hemisphere will experience spring equinox. As you can see the angle of sun rays falling on different latitudes. The length of the daylight will be equal 12 hours of day and 12 hours of night. While the Earth revolving about the sun, now will reach to the position where Earth will experience winter solstice, 21st of December. As you can see, Earth is tilted on its axis and the direct rays of the sun will fall on Tropic of Capricorn at 90 degree. As you can see, half part is illuminated and half part is in dark. Northern hemisphere will experience winter solstice and southern hemisphere will experience summer solstice. You can see the Arctic Circle and Antarctic Circle, the angle of rays falling on different latitude. Length of the daylight will vary. Places above Arctic Circle experience 24 hours of darkness. Places below Antarctic Circle will experience 24 hours of daylight. Now we learn the reasons for the seasons on Earth. This one is a very important topic in motions of the Earth. The seasons on Earth are caused by the 23 degree 30 minutes tilt on its own axis. That is the inclination of the Earth and supported by rotation. It is also supported by the position of the Earth around the Sun. As you can see in the diagram, summer is warmer than the winter in each hemisphere because the sun rays hit the Earth at more direct angle during the summer than the winter. As you can see in this diagram, the position of the Earth in summer solstice, direct rays of the sun is falling on Tropic of Cancer. The northern hemisphere will experience summer season and southern hemisphere will experience winter. Whereas on 22nd December, the direct rays of the sun will fall on Tropic of Capricorn at 90 degree angle and southern hemisphere will experience summer and northern hemisphere will experience winter. The tilt of the Earth's axis gives us the seasons. Apart from the tilt of the Earth's axis gives us the seasons, there are other factors supports rotation of the earth, revolution of the earth, inclination of the earth, and parallelism of the earth on its own axis. Now you'll understand what is parallelism. Earth on its own axis, the tilt of 23 degree 30 minutes on the vertical plane. Throughout the year, the earth, while is rotating on its own axis and same time also revolving about the earth, the axis of the earth will remain parallel to each other. There is no change in the parallelism of the earth axis. These are the primary reasons for the seasons on earth. Now we'll understand the phenomenon of season in detail. The four seasons, the effect of the tilt of the earth's rotational axis. As you can see in this diagram, it is very nicely explained over here. Earth's position at the center, and there are four positions of the earth and different point of time in the year. We'll take the first one, spring equinox, triggered on 21st March. Direct rays of sun will fall on equator and both the hemisphere will experience equal length of days, that is 12 hours of days and 12 hours of night. The journey continues. At this position, summer solstice will be triggered on 21st June. Direct rays of the sun will fall on northern hemisphere at 90 degree and northern hemisphere will experience summer and southern hemisphere experience winter. And the journey further continues. Now once again the earth will experience equal days and night. This position is called fall equinox or autumn. Direct rays of sunlight will fall on equator at 90 degree angle. Both the hemisphere will experience 12 hours of daylight and 12 hours of night. On 22nd September, both the hemisphere will experience equal length of days and night. Further, the journey continues. At this position, the winter solstice will trigger. Direct sunlight will fall on Tropic of Capricorn at 90 degree angle. Northern hemisphere will experience winter and southern hemisphere will experience summer. As you can see, these two pictures been shown over here. It has been zoomed. The first one, summer solstice, 21st June. Direct rays will fall on Tropic of Cancer. Northern hemisphere will experience summer and southern will experience winter. Another example has been shown over here with the help of the diagram. Direct sunlight will fall on Tropic of Capricorn, 22nd December. Southern hemisphere will experience summer and same time northern hemisphere will experience winter. Now we'll understand what is solstice. On 21st June and 22nd December, vertical rays of the sun will fall on tropics. Days are long and nights are short in the respective hemisphere. As you can see in this diagram, the direct rays are falling on Tropic of Cancer. At this point of time, the days will be longer and the nights will be shorter. But during winter solstice, direct rays will be falling on Tropic of Capricorn. In southern hemisphere, the days will be longer and nights will be shorter. It means longest day and shortest night. Now we'll understand what is equinox. On 21st March and 22nd September, the sun shines vertical over equator, equal days and night. 21st March and 22nd September. The position is called equinox, means equal days. On 21st March, the direct rays of the sun will fall on equator at 90 degree. Earth will experience equal length of day and equal length of night. It is also called vernal or spring equinox. On 22nd September, the direct rays of the sun will fall on equator, also experience equal length of days and equal length of night, is called autumnal equinox. Now we'll understand what is equinox and solstice with the help of a simulation. As you can see, the earth rotating on its own axis. At the same time, it is also revolving about the sun. It completes one revolution in 365 days or 1 year. The part facing toward the sun is illuminating. As you can observe that the part that is facing toward the sun is changing its position due to the rotation of the earth on its own axis. It completes one rotation in 24 hours. Earth at the March equinox, and the direct sunlight fall on equator. All locations on Earth will experience equal length of day and night, that is 12 hours of daylight. Earth at June solstice. As you can see, the direct rays are falling on Tropic of Cancer at 90 degrees. Now the northern hemisphere will experience summer. 24 hours of daylight will experience in Arctic Circle and 24 hours of darkness in southern hemisphere or Antarctic Circle, and 12 hours of daylight on equator. Earth at September equinox. As you can see, once again the Earth has reached to the position on September 22nd where the direct sunlight is falling on equator at 90-degree angle. All location on Earth will experience 12 hours of daylight, or you can say equal length of day and night. Earth at December solstice. Direct rays of the sun will fall on Tropic of Capricorn at 90-degree angle. As you can see, the northern hemisphere will experience darkness near Arctic Circle and southern hemisphere will experience 24 hours of daylight at Antarctic Circle. Thank you for watching the presentation.